Hello everyone, and welcome back to STEAM Aspirations. Today we'll be solving problem number 22 of the 2015 AMC aid. So let's get started. On June 1st, a group of students is standing in rows with 15 students in each row. On June 2nd, the same group is standing with all of the students in one long row. On June 3rd, the same group is standing with just one student in each row. On June 4th, the same group is standing with 6 students in each row. The process continues through June 12th with a different number of students per day. However, on June 13th, they cannot find a new way of organizing the students. What is the smallest possible number of students in the group? So let's first find the number of different students per row each day. So that's just going to be the number of days from June 1st to June 12th, which is just 12 different arrangements. And the key idea here is to notice that since the students are standing in rows, that means that they're standing in a rectangular formation with a constant area because there's the same number of students. And what this means is that every single arrangement is just a factor pair of the total number of students. And what I mean by this is, let's assume that there's 30 students. This is definitely not going to work here, but let's say they have 5 students in each row. And you can see they need 6 rows. So this would represent the factor pair 5 times 6. However, they could also have 6 students in each row, which is just going to represent the pair 6 times 5. So it's the number of factor pairs, and since these pairs are reversible, that means that this is just the number of factors. So if we let the number of students be n, we know that n has 12 factors. We also know from this question that since there's 15 students in one row, we know that 15 divides n. And we also know that since the same group is staying with 6 students in a row, we also know that 6 divides n. So this means that n is going to be equal to the least common multiple of 15 times and 6. The least common multiple of 15 and 6 is just 30 multiplied by k, which is some constant. And you know that the number of factors of an integer, say, let's just call this L. So the number of factors of L, given that L is equal to, not 2, P1 to the alpha 1, P2 to the alpha 2, etc., where P1, P2, etc. are primes, and alpha 1, alpha 2, etc. are exponents, is just going to be alpha 1 plus 1 multiplied by alpha 2 plus 1, etc. And you can think of this as just a counting problem. There's alpha 1 plus 1 ways to choose an exponent for P1, being 0 all the way through alpha 1. Same thing for alpha 2, etc. And by the multiplication rule, you just multiply this all together. So we know 30 is equal to 2 to the 1 multiplied by 3 to the 1 multiplied by 5 to the 1 multiplied by k. And we want we want the number of factors of this to equal 12. And we know 12 is equal to 2 times 2 times 3. And since we already have a 2 being contributed from 3 to the 1 and a 2 being contributed from 5 to the 1, we can just tack on another 2. And if we let k equals 2, this will become 2 to the 2 times 3 to the 1 times 5 to the 1, which will have 2 plus 1 times 3 and 1 plus 1 times 1 plus 1, which is equal to 12 factors. And this is the smallest possible one because 2 is the smallest prime and you can't really multiply it by anything. And if you multiply it by anything bigger than 2, then the result would be bigger. If you multiply it by 1, it would have 8 factors. So that means that the smallest possible number of students is 2 to the 2 times 3 to the 1 multiplied by 5 to the 1, which is going to be equal to 60. Choice C, and we are done. Thank you so much for watching this video. It really means a lot. Please don't forget to like, share, and subscribe, and click on the bell icon to get notified for new uploads. And as always, see you next time.